probe, and then there is a contact probe also, and there is a probe holder, and this is the workpiece with a micro hole. This is the top surface and this is the bottom surface of the component, and the details of the workpiece which has the micro hole are given here. So this is the schematic diagram of diesel fuel injector which has a micro holes. These are the micro holes of injector nozzle, and this is the needle, and here the fuel diesel will flow and it will come out of the nozzles. So these are these spray holes, and how these micro holes are made, the details are available here using micro hole EDM, using wire electrode. This is the wire electrode and this is the workpiece in which the micro hole is to be made. So using this EDM process, micro holes are fabricated. Now here we can see the arrangement setup for micro hole measurement. So in this first picture here we can see the overview of nozzle. This is the nozzle of the diesel engine injector nozzle, and this is the contact probe made of glass fiber probe, and this is the probe holder, and this is the optical vision sensor, optical lens vision probe. And in this picture we can see the close view of glass fiber probe. You can see the diameter at this point is 200 micrometer. At this point, diameter of the probe or the stem is 500 micrometer, and this is the tip of the probe, and this is the workpiece. And here we have a nozzle micro hole, and this picture shows spherical glass fiber probe tip. This is the probe tip, spherical probe tip with 74 micrometer diameter. And this image is captured by the CCD image sensor. So the measurement results are diameter of 3 microholes are measured. The diameter is 157 micrometer, 158 micrometer and 160 micrometer. So using CMM, very small holes, micro holes also can be measured. Now let us discuss how we can carry out preventive maintenance on coordinate measuring machines. Each of the 3 axes of CMM has a scale and encoder head for determining its position during travel. We should rub the scale lightly in one direction with a denatured alcohol soaked cotton ball to clean the scale. This generally needs to be done only twice in a year. The encoder head is not to be cleaned except by a trained service technician. So keeping the scale clean will keep the encoder clean. Although the X and Y axis scales are exposed, the Z axis scale is covered, so we should remove the tower cover to clean the Z axis. There are ground surfaces located on the bridge, leg rail and probe bar. These should be kept free of rust and debris, and they should be cleaned at least once in a month. To clean these surfaces, we should use denatured alcohol and a lint-free cloth, and then we should follow up with an application of a thin coat of light oil, again using a lint-free cloth. The probe bar should be cleaned and lubricated daily, at least each day that is used. in the same manner as ground surfaces to prevent rusting. Since the granite table is a porous material, we should clean the greasy layer and oily layer from the work parts to be inspected. Otherwise, oil will enter into the pores in the granite. So we should not place the foreign objects on the granite plate, and we should remove inspected parts quickly from the table surface. Rust can form and stain if the workpieces are left on the plate. Stains can be reduced using a light amount of denatured alcohol and medium grade scoring pad. We should use only a light amount of special surface plate cleaner and lint-free cloth to clean the surface workpiece table surface, and we should allow to fully dry before placing the parts on the table. The granite plate should be kept level for best results. We should use a 0.125 millimeter per 30 centimeter bubble level, and we should adjust the knobs at the bottom of the table legs. If required, we should check this condition periodically. We can always use a gram gauge for adjustment, reset and checking of probe trigger force settings on touch trigger probes. Setting the optimum trigger force using the gram gauge maximizes a probe's performance. The gram gauge can be used to set trigger force settings over a range of 4 to 35 grams. The scale graduation are set at 1 gram intervals, which is sufficient for all probe trigger force measurements on coordinate measuring machines. Here we can see the gram gauges. These are analog gram gauges. The least count of this gram gauge is 1 gram, and in this case it is 10 grams, and the digital gram gauges are also available. Using these gram gauges we can set the force, trigger force. The conversion factor is 1 gram force is equal to 0.01 newtons. Now let us study what are the advantages of coordinate measuring machines. The very first advantage is the flexibility. Coordinate measuring machines are essentially universal measuring machines, and they need not be dedicated to any particular task. They can measure almost any